for coming to this channel. Welcome to the channel. In our former class, we discussed about dimensions and we said a little more about dimensions, about quantities rather. We want to discuss about dimensions in this particular class. Discuss a little bit about dimensions and how we can find the dimension of a particular quantity if we are being given questions on that. Okay, physics. Dimensions. First of all, what are dimensions in physics? Dimensions are, or is a way in physics where we look at how a quantity is being related to basic units. For instance, if we have a quantity like, okay, before we go into dimensions, let us check which fundamental quantity is used to find out the dimension of a quantity. The three fundamental quantities that are being used are the mass, the length, and the time. What is the mass of a particular body? The mass of a body can be defined as the amount of matter that a particular body has, and that is different from the weight. Now, most people don't really understand the difference between mass and weight. Mass does not vary because it defines how much matter does a body contains. So, but weight defines how much gravitational pull does a body have, or does the earth have against the body. For instance, you know the law of gravity, that all bodies are being put toward the center of the earth. How much force is acting on a particular body? That's what we now talk about, the weight. But when we talk about the mass, we are saying how much matter is constituted in a body. That's the mass rather. Then as for the length, we say length is what? The distance between 2 points of a material or of a body. When we measure the distance between 2 points of a body, we say that's the length. And the time is simply the amount or the sequence in which an event occurs. That talks about the time. So if I give a sequence in which an event occurred, I'm simply expressing that particular event per time. And we know that the unit for all of this, for mass, the standard unit is kilograms. For length, the standard unit is meters. But for time, the standard unit is what? Is time, is seconds rather. And then, but when we want to describe this in terms of dimensions, the symbol used for mass is capital M. The symbol used for length is capital L. And the symbol used for time is capital what? Capital T. And then we now say, okay, when you are describing the dimension of a particular quantity, we are describing that quantity in terms of these three symbols here. And M represents the mass, L represents the length, T represents the time. Now, each quantity is directly or indirectly linked with mass, length, and time, one way or another. So, any place you see, for instance, you may not really see length, but you may see distance. So you still use the length. You may not really see time. Okay, most times it's always time, but you may not really see weight and mass. You may see weight, but you can still use what? Capital M. So let us go ahead to find out the dimensions of some physical quantities. For instance, let us see in place one like area. The formula for area is length times length for a square area. And of course, we have length here, so we just put capital L multiplied by this other length, we use capital L, equals to what? From indices, when you have two numbers or two letters of the same base, we can just simply pick one and add the powers. Now the base here is L and L. We can pick one base, L, and add the powers. The power here is 1. Like I normally say, when you don't see anything, assume that 1 is the power. When there's no power, you assume that 1 is the power. So we can assume that 1 is here and also assume that 1 is here. So 1 plus 1 is what? 2. So that's a dimension for area, L squared. If we want to take the dimension for volume, we can simply say that, volume is area times height. So you can simply say area, or sorry, volume equals the area times the height. Right? Very good. Now, we know that the area already was L squared from our former example. our previous example, L squared multiplied by. Now, we have height here. Amongst these three fundamental quantities, which one can you link height to? You cannot link height to mass. You cannot link height to time. You can link height to the length. So we can still put L here. Like what I said before, that each of the quantities is directly or indirectly linked with each of these fundamental quantities. So you can put L there. And like I said in indices, you pick one base and add the powers. 2 plus 1 is what? L to the power of 3. Alright, so those are the basic ones. We can go further to find the dimension for quantities like speed or velocity. You know, speed and velocity, they are the same, except for speed, we don't talk about the direction. Now, speed, the formula for speed is what? Distance divided by the time taken. Alright, now, among these three quantities, which one can you relate distance with? The length. Have you seen that in a way we still look for a way to relate each quantities with what? With the fundamental quantities. So distance can be related with the length. We say L all over what? Time here is what? Capital T. So we say here is what? L. If we bring T up to the numerator, what do we do to the T? We add -1 as the power. So we can also find the quantity or the dimension for acceleration. And what the formula for acceleration? Change in velocity all over time. Change in velocity. Change in velocity divided by the time taken for the change. And remember that I told you that velocity and speed, they have the same dimension rather. So if speed is Lt minus 1 all over, what is time taken? Time is capital T. So you can simply, let's use here, you can simply say Lt minus 1. We can bring this T to the numerator by saying multiply by T to the power minus 1. Now we now say L T to the power minus 1. We can pick one base because both of them have the same base, T. We can pick one base and add the powers. Minus 1 plus minus 1 is what? -2. So T to the power of -2. So you now come to realize that we can keep using this method. Let me do for maybe first, then I'll give you an assignment. Now we keep using this method to have plenty dimensions because we just need to relate them back to these dimensions. Just relate them back to the dimensions, and we try our best to carry out our arithmetic. Let us go in for force. What's the formula for force? The mass of an object multiplied by its what? Acceleration due to gravity. And remember that the mass is what? Capital M. We represent the mass by what? Capital M. We represent acceleration by what? Lt to the power minus what? 2. We can now say this is what? M Lt to the power minus 2. So this is how it is. Now, I didn't want to bring this particular thing I want to say now at the beginning of the video. Let me say it now that I've actually solved for this. You're now going to realize that anytime you're having a dimension that contains all the three letters, we start with M, then L, then T. So it is not as if it is wrong for you to say something like T to the power minus 2 ml. It is not wrong. It is just physically incorrect. So just follow the pattern mlt raised to the power minus 2 and you get it right.